So when we find that confidence coefficient, the R, we can use it to help us determine if two variables, if the relationship between them is statistically significant. So if the correlation coefficient is less than 0.5, there's probably not going to be a significant correlation between the two. But if the sample size is at least 30, we can be fairly confident of a linear correlation if R is equal to 0.5. We have to look at the sample size and the level of confidence that we want to have to find this statistical significance. Level of confidence then is denoted by C. We just use the letter C, and it is the level of confidence. It's the probability that the assertions we made about the data are correct. So the probability of a linear correlation, we could say is correct, or it's correct what percent of the time. That's what we're talking about. Level C is what percent of the time we're right. The level of significance is denoted by alpha, and that's the probability that we're wrong. So the two have to add up to 1 because they're probabilities, and probabilities always go between 0 and 1. And so if we have let's say a 40% probability of being incorrect, then we have a 60% probability of being correct. That's all we're talking about here. So the two should always add up, and we use C for the level of confidence, how confident we are of our results, and alpha we use for the level of significance. Level of significance is what percent or what probability is that we are wrong. So let's interpret. Find alpha if C is 0.95. So we can do 1 minus C equals alpha. Because we can take this equation, C plus alpha equals 1, and we can just subtract C from both sides of it, and we get alpha equals 1 minus C. That's one version. We can also come back to this formula, C plus alpha equals 1, and we can subtract alpha from both sides, and then we get C equals 1 minus alpha. So depending which one we're given, we can take the other one away from 1, and we'll know the one that we weren't given. So depending on which one we were given, we can take it away from 1, and then we'll know the one that we weren't given. So in this case, we were given the C, and so we take it away from 1 to find the alpha. So we'll have 1 minus 0.95 equals alpha, and 1 minus 0.95 is 0.05, and so that's our alpha. So then we want to interpret both measures. So we would say, so the level of confidence, 0.95, means that we are 95% certain that we are accurate. The level of significance of 0.05 means 5% of the time we are incorrect, and that's the alpha value that we have here. Try out this next problem, especially the interpretations, and see what you get.